Yeah, good morning. It's your teacher that the course will be continuing from our last class to end our topic on water. Remember I told you in the last class that I will tell you about anomalous behavior of water. This is where I'm going to tell you. But before we do that, let's talk about how to test for the presence of water. Now pay attention. This is not testing whether a substance is water. We are testing whether a substance contains water. That is, wherever water is, this kind of reaction will always occur. The most common compound that is used for testing for the presence of water is called, you want to know it, is called anhydrous copper 2 tetraoxosulfate 6. Now, if you add water to a white anhydrous, the one you are seeing in the test tube, if you add water to a white anhydrous copper sulfate, it's going to turn blue, and that shows that that substance contains water. Remember, we are testing for presence of water. We are not testing for water. That thing may not be water, but it may be containing water, and this reaction will occur. So you can see this blue substance now, that's where water touches, it's going to turn blue, but initially it is white. So that's how you use copper sulfate to test for the presence of water. So when you add water to that copper sulfate, white anhydrous copper sulfate, anhydrous means no water oxidation, then when you now add water there, it turns blue. That's why you're having a blue color, because the salt will now become hydrated. Remember I told you under water oxidation that water oxidation normally add color and shape to a particular salt. So we can see an example in this place how we are using to test for water. So you can see this equation that we have here. Copper sulfate, this one is white. This copper sulfate is already white. Now, if you add water to it, it's going to give you copper sulfate 5 of water. This is the hydrated salt, hydrated copper sulfate, which is blue in color. This is the anhydrous, the one without any water oxidation, is white in color. So you can check that. So white copper sulfate anhydrous gives you blue copper sulfate hydrated. Blue copper sulfate hydrated. So this is blue, it has been hydrated. This is white. So that's how you test for the presence of water. Don't forget that. Add the unknown liquid to white anhydrous copper 2 tetraoxosulfate 6. If the white anhydrous salt turns blue, then the unknown liquid contains water. You can be asked in your exam to write the test for the presence of water. Now, another substance you can use to test for water is called CuSO4 chloride. The color of CuSO4 chloride is blue when there's no water there, but when you add water there, it turns pink. So let us see the test for water using CuSO4 chloride. You add the quantity of the unknown liquid to a blue anhydrous CuSO4 chloride. If the blue salt turns pink, then the unknown liquid is water. The unknown liquid is water. Now let us see the question that is there. This CuSO4 chloride anhydrous is blue in color, but when it is hydrated with water, it becomes what? It becomes pink. So blue CuSO4 chloride, then we have pink hydrated CuSO4 chloride. So it is pink when it is hydrated, it is blue when it is anhydrous. Please don't mistake it for copper sulfate. Copper sulfate is white when it is anhydrous, and it is blue when you add water. But CuSO4 chloride is blue when you have not added water, it's going to turn pink after addition of water. That's the test for the presence of water. Finally, before this class will end, let's talk about the anomalous behavior of water. That is the unusual, the abnormal behavior of water. Let's talk about it now. The anomalous behavior of water. Number one, the melting and boiling point of water are unusually high. Water is just a molecule of 18 grams, but the boiling point is 100 degrees Celsius. That is an unusual behavior. And what causes this high boiling point is because of the ability to form hydrogen bonding. Don't forget that there's hydrogen bonding inside water. We said it from the beginning of this class. So that hydrogen bonding makes water to have an unusual high boiling point. Let's see another anomalous behavior of water. The high surface tension that water has, it produces a skin-like effect. A skin-like effect on water surface. You know, the surface of water is like a tightly stretched skin. It has a very high surface tension, and this is also due to the presence of hydrogen bonding. Don't forget, hydrogen bonding has to occur when a molecule of water is attracting another molecule of water. That's called hydrogen bonding. It's responsible for the high melting and boiling point. It's also responsible for the high surface tension of water. Now, the most very abnormal boiling point of water, the abnormal behavior of water is that the solid form of water is not as dense as the liquid form. What we always know is that solid is denser than liquid, but in the case of water, the reverse is the case. The liquid water is denser than the solid water. That is why you observe that ice normally floats in water. Look at this particular structure, this particular picture. You see that this iceberg did not touch the ground. It's actually floating, and you can see the tip of the iceberg also outside. The reason is because liquid water is actually denser than solid water, which is ice. The density of liquid water is 1 gram per cm cube. You remember that. But the density of solid water is 0.99 gram per cm cube. Meaning that if you drop ice inside the water, only 99% of the ice will enter in the water. The rest will float. The remaining 1% will flow. So the water will not be sinking. The ice will not be sinking into the water because the liquid water is more dense than the solid water. This is an anomalous or an abnormal behavior. You can also see what we experience in ice cube or iced tea. So in iced tea, you put the ice inside the water, the ice will be floating, it will not sink. So that shows you that ice is less dense than a solid water, and the reason is because of the hydrogen bonding. Hydrogen bonding spread out the molecules of water in ice. So because of all the spreading, there's a lot of spaces there that reduces the density. But in liquid water, the particles are more closely packed. You can see an abnormality now where particles are less closely packed in solid than in liquid. It doesn't occur like that, and this is why the liquid water is denser than the solid water, and therefore ice will normally float on water. God bless you. That is the end of our class.